So we're going to go to a GPS project now. Yeah. Okay. So we go to static topography, and we go down here to the step 1, which is extract GPS vector topo. And what that does is, for every profile inside your project, it's going to compile the third column, which is the elevation of the GPS. So we compile EC northings and the elevation. And particularly if you have good enough GPS, you can use the GPS as your digital elevation model. And so the button here just goes into those files which exist in the raw folder for every project and compiles all that data. And with that, we then grid the digital elevation model from GPS. And I'm actually going to change the blanking radius here, where we're only going to search out 1 meter. And with that, you'll be able to see the actual track of the GPS over the site. And that's almost finished. And that's showing the track of the GPS. Well, we wouldn't want to create that digital elevation model. So we need to really fill that all in. So I'm just going to put in a larger blanking radius and let this run one more time. And just to note, the topographic grid has to encompass all of the data grid as well. So usually the blanking radius should be slightly larger than the blanking radius you used for creating the 3D volume. So there's our grid has been made. And then it says exit to OpenGL topo volume work, where we do real-time topographic corrections. And we can actually put up a picture of the site. This is a site in Indiana, a Strawtown archaeological site. And there's an Indian dwelling on the site. And this is a platform. And that's showing the elevation there. And again, the ZT are the topographic slices. We can actually put on the ZL, which are the level plane slices. These aren't quite as interesting, but it's slicing through the topography. And you can also put on the topographically corrected radiogram. Now, this particular site, this is like a 23,000 scan profile with only about 200 samples in the depth. So that's good enough to get an OpenGL. But if you had a 100,000 scan profile that was digitized at 1024, it probably wouldn't render completely. We do have this option here in GPR Slice where if you have a large profile and you want to look behind the profile or data inside here, you can actually choose a scan length. Let's say I chose a scan length of 500. You can hit R+, and then hit this bounce button, and you can actually see how the data was recorded on the site. And you can actually change the length of this to whatever is a convenient length so that you could see past it. And you can actually hit the button called Store and see this continuing on. And you can rotate it around. And if you wanted to store that one part, you could store that part. I just hit the Store button again. And then so you can look at the different parts of the data more conveniently. Okay. And I'm just going to stop that and just put up the entire profile again one more time, because it looked very impressive there. Okay, so there's the using GPS for the GPS elevations to create the digital elevation model. Okay, in terms of topographic adjustments, those are the 3 ways to do it. You can draw topography, you could import a digital elevation model on a local grid, or you can even import a digital elevation model on a GPS grid because the GPS wasn't working well enough, or you can use the GPS information. Okay, what we'd like to do now is we'd like to move on and just introduce vector imaging to you.